Hello guys, today we are going to look into algorithm to find the minimum element in sorted rotated array. So you will be given an array which is sorted and rotated n number of times. You need to find the minimum element in the array. Given this problem, we need to we should think of using binary search whenever we are given a problem which has say that the array input is sorted and you need to find some element, you need to search for this element. We should always think of using binary search, and that is the hint given in the problem as well. uh, so so to understand this problem, we need to understand how binary search works. Let's see how binary search work. I'll give you an overview of how binary search works and what is the time complexity, and then I'll jump into this algorithm. So I will take a different problem and try to solve it using binary search in a different video. I will put that link in this comment section. So how binary search work is, given an array, it will try to sort the array, and if we are searching for a particular element, uh, it goes and checks, finds the middle element in the array. If the element that we are checking is the middle element of the array, it returns it. Else, if the element is less than the middle element, it will search in the from the 0 to mid minus 1 part of it. Why? Because since the array is sorted, we need not go and check the entire array, because we know that element has to be in the left part of it. If not, it will search in the right part of it. At any point of time, it divides the array into two, and it searches for only the element in half. So the even input is divided by 2, and it finally goes to that appropriate element, which is the middle element. So the time complexity of binary search is log n, because it divides the input into two and it operates only on the half of the input that is given to that algorithm at any point of time. So that's why it is fast as well. So let's jump into this algorithm after we looked into, since we have looked into binary search. Let's look into these boundary conditions little later. Let's directly jump into how this algorithm works. For a binary search, we need to, as I said, we have to find the middle element. Mid is the low plus high by 2. Middle index, it's not the middle element, it's the middle index. If the element at the middle index is less than the element at the lowest index, and the element at the mid index is less than mid plus 1. So what is this condition? Take this array 5 6 7 1 2 3 4, and the element at mid index is 1. If the element is less than the lower index, which is 5, yes, and if the element is less than the mid plus 1 index, which is 2, then that is the minimum element, because because this is the lowest element, and the element towards is left has to be smaller, but we are checking for the smallest element, which should start from left, and that itself is greater than, and we have found an element where we have spiked down. So that is the minimum element. Why it is not 7? Because it is a sorted and rotated array. If the leftmost element is smaller, and all the elements towards its right has to be greater, till we find the element where it drops down, which spikes down. So why it cannot be in the right as well? Because we are checking that the mid plus 1 element is greater than it, and since this is a sorted rotated array, any element towards its right hand side has to be greater than it, and the element. So that's when we come to a conclusion that we have found the element. Hopefully the explanation was clear. If not, comment it. I will take a different input and explain you in a different video as well. Or else I can do a whiteboarding by taking 2-3 inputs. Next is the meat. How are we finding that whether the element is left hand side or in the right hand side? If the lower the element at the mid index is greater than the element at the lower index, and the element is mid index is less than the mid plus 1, then we need to search for the element in the left hand side or the lower left hand side of the array. Element at mid. So let's take an example of the same array 5 6 7 1 2 3. Now we have found an array subarray which is 5 6 7, and we need to find what is the minimum, sorry guys, and we need to find the minimum element in 5 6 7. So what is the middle element? It is middle index, it is 1, which is 6. Is 6 greater than 5? Yes. And 6 less than 7? That is also yes. 7 is mid plus 1, 6 is mid, and on the left hand side it can be more than one element as well. So we have to find the element in the left hand side. We are ensuring that the element towards its right is greater than, so we are searching for the element in the left hand side. We ignore 1 2 3 4, what is that present in the right hand side. And this is, I'm just taking the subarray to explain how this condition goes. Or take 1 2 3 4. So we have found we have the array 1 subarray. Here we assume that we are taking the array 1 2 3. The middle element is 2. Is 2 greater than 1? Yes, true. And the 2 greater than 3, that is also true. Then we have to find the element which is on the left hand side. Assume that there are more elements like 0 minus 1 or whatever it is. So the element has to be in the left half of the array. So that's what we are searching. Otherwise we have to go and check the element in the mid plus 1 to high. And yeah, that is it. And what is the boundary condition here? If high less than low, when we are moving the pointers of low and high, if at any point of time the high pointer goes to uh, below the low pointer, we say that the zeroth element is the the smallest element in the array. That can happen in this array. So if high equal to low, if we have arrived at a pointer where the pointer of high and the pointer of low is same and return low, we can return high as well, but yes, we return the low. So these are the two boundary conditions that we need to check to find whether we have found the element or not. So that is it. Let me run this problem from the driver code. Usually we have the habit of writing test cases for doing it. I'm just showing the driver code from the main, but I will show the test cases as well in a different place. 4 5 1 2 3, the minimum element is 1. 5 6 1 2 3 4, the minimum element is 1. 1 2 3 4, the minimum element is 1. 5 6 7 1 2 3 4, the minimum element is 1. So given all these inputs, we are able to find the minimum element in the sorted rotated array all the time. So that is it. And this problem is asked by many companies, Microsoft, Amazon, and Morgan Stanley, and banks as well. So have a thorough understanding of how do we search for an element in a sorted rotated array. How do we find the minimum? The other versions of this problem are how do you find an element in a sorted rotated array? How do you find the minimum element in the sorted rotated array? How do you find the maximum element in the sorted rotated array? These are the variations of it, which the interviewer in many companies they may change a little bit and ask the problem, but the gist is same. We need to use binary search to solve this problem. If you become hands-on in binary search, then we should be able to crack this problem in no time. Thanks for your time. Let's meet with a different problem in different day. Bye.